Yes, it's time to make another omnidirectional bike. The 3 previous ones featured 1 Omni wheel on a bicycle, 2 Omni wheels which balanced sideways, and then it had to be blown along with fans, and then I tried 4 mechanism wheels so the bike can move in any direction but also screw itself along forwards and backwards. And of course you can check all of those out in my channel. This time though, I'm going to try and make a bike which balances on 2 balls which can roll in any direction. These are rigid balls called walking globes, and they're used by circus acts to balance on, and this is the sort of thing you can buy in juggling shops. These are totally rigid and include a stopper for filling them with sand to slow them down, but I'll be leaving them totally hollow. They really are really round, so they roll really well. I'm going to use 3 Omni wheels to drive each ball, which have little wheels all around them so they can slide sideways. I previously made a ball balancing robot like this which worked okay, but I had issues at high velocity because the wheels seemed to fight each other. This time I'm going to turn the wheels around 90 degrees, which should allow the ball to roll faster, but I'm only going to power 2 of the wheels and leave the third as an idler. So it's really important that the bike can balance sideways and balance sideways like a Segway or a hoverboard to stay upright, because otherwise it's going to be impossible to drive. So we've got the wheels at this orientation where we've got them 120 degrees apart, and that's so we can drive sideways, and we can also drive forwards and backwards by spinning those wheels in opposite directions to get linear travel this way. However, with the wheels like that, and the Omni wheels having the little wheels, I'm not sure if there's going to be like weird slippage and we won't get linear velocity between the wheel velocity and the ball, and whether the ball will just like spin round instead of going sideways in a weird way, because all those little wheels will allow it to actually freely rotate. If that happens, then we're going to have to motorise the third wheel, which is planned to be an idler, but that one will then need to turn round 90 degrees so it has some effect to actually drive it sideways. Anyway, I'm about 90% sure it'll work like this, but I've never built a ball balancing robot with the wheels in that orientation, so I think all we can really do is go and build it and find out if it works. So it's time to 3D print some parts. There's quite a lot of large chunky parts to print for this, so thanks to my 3D printing sponsor, which is Lolsbot 3D printers, I'm using the 1.2mm nozzle to make lots of these parts. So you can see how fat those extrusions are, how fat the infill is, and how big those parts are, and there's several of those to support all of those Omni wheels at 120 degrees apart. This one has support material in to put in some 40/40 extrusion, but on the whole there's huge chunky parts going to make up the structure. There's also some parts printed with a thinner nozzle, and those to allow tolerancing so that we can insert them in the fatter parts and use them to hold bearings and so on. Thanks to 3D Fuel for the filament for this project, you can now get 10% off at 3dfuel.com with my special code and link, and I'll get a small commission. We're going to be using ODrives for this project, which was the same on the screw bike. These are 8325 motors, and they have a magnet on the back so that we can put the ODrive S1 driver sandwiched on the back, and it can control position, velocity or torque. These come in a kit with all the mounting plates, and we've got 4 of those in total, so we've got 1 of those to drive each of the 4 driven wheels out of 6. Each motor is mounted on a 3D printed plate, and that plate is attached to one of the big chunks made with a 1.2mm nozzle, so that fits neatly in there so I can get to the connectors. Thanks to Simply Bearings for the bearings for this project. There are lots of bearings in the wheels and in the idlers and everywhere else. So this thing comes in 2 sides. We've got those pieces I made with a finer nozzle that we can insert those bearings in. The bearings are pushed in either end, and then those black things are going to get inserted into the chunky prints, and you can see that that's really well toleranced. So those get glued in, and that means I only have to reprint that part should the tolerancing be bad rather than the whole thing. So here are our Omni wheel assemblies. These come in 2 halves with a spacer in between, and that is fitted onto a square axle made of 2020 extrusion with a pulley on one side and a spacer on the other, which basically connects to the 2020 and holds everything firm. And of course those roll in one direction and slide in the other. We've got 2 drive belts in our gearbox and an intermediate pulley. This is essentially a converter from a T5 to an HDD8, and this is actually not much of a reduction, but it's the same reduction that we had in the screw bike, and so taking into account the ball diameter, we should get the same velocity on the wheel. So obviously that intermediate gear sits in between the motor and the wheel itself, and it offers some reduction, but not much. So we now have the other half to insert, which has bearings, a little stud that goes in the motor to hold it, and a hole for that pulley so that everything is tensioned and everything stays tight. Here is one assembled unit, so we should find that we've got that intermediate pulley, the wheel, the motor, and all of those belts are tensioned and everything is double braced at both ends of the axle, so that's nicely back drivable and everything moves smoothly. And on the other side we've got this curved cutout, which is where the ball is going to sit, and that wheel of course is going to rest on the ball to drive it. There are 4 of these that I've had to assemble for our 4-driven units to drive our 2 balls. So those are looking pretty good, and I did remember to make mirrored pairs of course. These are looking pretty good, and my belts are actually pretty tight on all of these. I've left provision to put an idler in on each of the belts if I want to tighten the belts up if they stretch, but basically just the spacing looks perfect at the moment. And hopefully, if I've worked this out right, then we should have the same reduction onto these wheels, taking into account the ball that we did have with the screw bike, so we should have enough power. But I'm just going to power one of these up and see how torquey it is. The ODrive tool allows me to run this and monitor the velocity, current and the position of each of the motors. Just going to do 5 revolutions a second on the motor, and then we've got this reduction, which isn't very much, but ow god, that's pretty tough actually. That's alright, let's just try a bit more. That's about 11 revolutions a second. I definitely can't stop that. And it'll go all the way up to about between 60 and 80. So we should have enough velocity. So that seems pretty good. We've got a lot of torque at low speed and we've got velocity overhead, which is what we need for a balancing robot really, for any type of thing. If you don't have enough torque at low speed, it won't be able to balance. Obviously this has got to run on the balls, all 4 motors going sideways, so we should have even more power. And then it's got to balance me on top and all of the bike. And this is running on 50 volts at the moment, so we can push nearly 2 kilowatts out of each of these motors at 40 amps. So now it's time to put a frame to put it all on. Instead of welded steel this time, I think I want to be able to shift this around and adjust it. So I'm going to use 4040 T-slot aluminium extrusion. As usual, I'm using T-nuts that slot into the slots and they allow bolts to be bolted in to hold the whole thing together. As well as some off-the-shelf extrusions, which are pretty rigid, we're also going to need some custom-made aluminium parts to hold all of this together. And that means it's time for a quick ad from the video's sponsor, which is PCBWay. As well as manufacturing various types of printed circuit board, such as rigid PCBs, flexible PCBs, rigid flex PCBs, which are part rigid and part flexible, and aluminium PCBs, PCBWay also carry out contract manufacturing, including 3D printing, injection moulding, sheet metal fabrication, and CNC services in various materials, such as aluminium, brass, carbon fibre, titanium, and others. PCBWay are a one-stop shop, all under one roof. It's easy to get a quote from PCBWay. Just upload your files, choose what material and finish you want, and you'll get a quote. I wanted to get a number of aluminium plates made for this project, and they're all 2D plates in this case, but PCBWay can of course manufacture much more complicated parts. The lead time was about 6 to 8 days for these, and they all shipped pretty quick too. Here are the plates I ordered. They all look pretty good. These fit onto various surfaces of the motor reduction unit and help with attaching them to the extrusions. I also made a lid which holds the 3D printed motor plate rigid and keeps the spacing between the 2 halves of the reduction unit correct. I left some spaces in those big prints for some 4040 extrusions, which are a pretty good press fit, but we do need some more aluminium plates cut by PCBWay, which bolt onto T-nuts like this, and they're also screwed onto the plastic each side. There's several of those, and those hold to 2 extrusions between each pair of drive units. There are some right angle brackets, which are going to fit the main crossbar of the bike, so more extrusions go that way, and that piece is 6 feet long and has the 2 idlers on each end. So those wheels of course rotate freely, there's no motor, they're on square axles again with bushings in the bearings, and they slide sideways. I already put the T-nuts in and held those in place with tape so they don't slip away, and those are for all of the other things that need to go on, like these drive units. So the pairs saddle on there with those brackets and they screw into those T-nuts that I placed there. So each end has, of course, one of those saddles with 2 drive units on. Alright, let's put this ball in and see what happens. Just going to stick some tape on here so we can see it moving, because otherwise in the video it just looks like it's plain red, doesn't it? Let's put some markers on here. We'll be able to see as we rotate it whether the wheels have traction, which is the main thing that I'm worried about. So let's put this on. Right. So now if I spin these wheels towards me, it should rotate the ball away, which seems to be working. So that means the bike would go this way, and if I spin them the other way, I should find it comes towards me this way, and that seems to be working as well. So that's pretty good. If I spin them in opposite directions, then it does look like, in fact, it's turning the way I expect it to, and because there's going to be two, they should keep each other in line, so it moves directly sideways. So I'm pretty happy that we only need 4 motorised wheels. This idler around here doesn't actually need to have a motor on, so that's looking pretty good. And what happens if I turn this? Oh yeah, it's actually having quite a lot of traction with those wheels. They're back driving, and obviously my mass would be on this as well, holding them. So I'm actually very hopeful this is going to work at the moment. Ooh, this is going to be good if it works. So wheel slip here is what I'm worried about. I'm getting these wheels perfectly aligned, so the 2 rows are sort of as flat on the ball as possible is quite important, but that's actually running really well, even with no mass on, just the mass of the ball, let alone the bike up the other way up, basically, with me on top of it. So that is looking very good, and of course they idle round that way perfectly well. Very nice. I fitted some more extrusions, which basically make up the body of the bike, and some of the electronics and batteries and things is going to live in there. Right, this is quite big. This is going to be pretty cool if it works, but we're not going to know till we build some power systems, some electronics to make it balance sideways and basically make it drive, and then we're going to need some twist grips or some sort of steering device on handlebars and a salad to sit on. We've got a contactor mounted in a box here with some terminals, and this is a 500 amp relay basically, which can turn all the power off, and that's going to be linked to an e-stop and also cables going out from that to all of the motors. So there it is, sat in the middle of the bike there with the batteries in a box, which consists of 6 6S LiPos, which are wired in series pairs and then in parallel to those terminals next to the contactor. They've also got 24 volts of LiPos to turn the contactor on and other features on the bike. This is the electronics unit I've built, which inside has a bunch of stuff on the control panel, which we'll look at in a minute, and on the other side has a Teensy 4.1 with its CAN bus transceiver to link to the ODrives, and also the BNO 086 IMU from SparkFun Electronics that I've used in a lot of projects, and that one is very good. Attached to the box is a USB programming cable, the DC power jack, an XLR for the CAN bus, an interface to the handlebars, and various other connectors for the meter and the contactor switch. I'm using this camera battery, which is in a sort of tray there, and when we power it up we get 7.4 volts for the electronics. Of course we've got the e-stop button and engine start that initiates the ODrives, and we've got 2 meters for the 24 and 50 volts. There's an LED spirit level so we can see that the IMU is working, and we've also got 2 pots. Now one of those is for the trim control, you can see the spirit level moving there, and the other one is for overall gain. We've got a blanking plate so I can put some extra knobs on that I've probably forgotten, and that electronics enclosure fits onto the main crossbar of the bike so we can measure the angle. Let's turn that e-stop off, which should power up all the ODrives, so they've all got their power LED on from the 50 volts, but we don't have anything to connect the CAN bus, so I need to build some wiring. I've made some temporary wiring out of some twisted pairs, and just put those between all of the CAN bus connectors, and those are daisy chained. So now if we turn it on and we initiate the ODrives, they're flashing green now, slowly turn up that gain, then we should find all the wheels turn. I've got PID parameters, which are the same ones from the screw bike for balancing, so you should check that video out for more information about balancing robots, and that is making the wheels turn with what looks like the right characteristics. It's really important that this balances sideways, like a Segway, but sideways instead of back and forward, because otherwise it's going to be impossible to ride. So the wheels turn in the right direction based on the IMU data, and we've got the same PID parameters for balancing as we had in the screw bike, and roughly the same reduction to the wheels, taking into account the diameter of the ball. So hopefully those parameters will be a good starting spot for tuning PID and getting it balancing. So it should just work. My concern is that all of the idlers on these wheels are all in the same direction, which means the ball is actually pretty free to spin round like this. So I'm hoping that we get the actual predictable velocity on the wheels from the motors being at an angle like this, and we don't just get some weird like thing that happens when there's friction on where the ball slightly spins instead of going sideways. And I haven't really been able to predict what's going to happen. I'm just really hoping it's going to work. So let's power it up and see what happens. Right, let's try it. Let's turn the e-stop off. Start the motors. Ooh. Turn up that gain. Okay. Just have a look at that trim control. Wow. Right. Okay. It looks like it's balancing. Probably does need some gains adjusting. And the question is, can I ride on it? Right. Seems pretty stable. What happens if I get on it? Now I've got foot pegs already, but nothing else, so I just need to put my hands really near the motors, which isn't too good. But that does in fact seem to be balancing me. We probably need to adjust the gains because it's a bit jittery, probably because the motors aren't perfectly perpendicular with the ball as they would have been in the screw bike. But this is definitely working, which means we've got good traction with the ball, and we've got obviously the ball's moving completely in the right direction. I can see the ball turning there to balance it, so that front wheel should just be idling, going sideways. This is looking very good. I think this is going to take the place for the best thing I've ever built since the screw bike, and hopefully it goes forwards really well as well by adding a bit to all of the motors to wind it forward, and we should be able to turn. But for now I want to put some handlebars and a saddle on, and then we'll need some controls, and we do need to adjust these PID parameters, but let's put all the extra mass on it first. Yeah, this is going to be pretty good. Right. So I've redone the CAN bus wiring and put those wires through strain relieves. These are now shielded cables, and they all run through some little holders, little cable trays there back to the electronics. Same with the front ones, that XLR connects the shielded cable. We've got the connector there for the handlebar controls when I put them on, and we've also got idlers on the T5 belts, so there's 2 bolts pushing those down on that strain relief assembly, just because some of the belts are a bit loose. I've got some substantial steel handlebars made of stainless steel tube and a headlamp. And we've got a seat, which is very similar to the screw bike, which I just bought on Amazon. Right, it's pretty good with the handlebars on. I've tuned up those PIDs, so this seems pretty responsive now. So now we just need some twist grips and some controls so that we can turn and we can drive forward, and hopefully that's going to work all right. So we've got this 3D printed lightsaber looking thing, which has got a piece on the end which is an extension, and that push fits on with some steel bars to hold it in place. First of all, we've got a little collar that goes around, and that rotates on the first piece against a stopper there, so it'll be sprung against that eventually. Then we can put the end on, which is a very tight push fit on 3mm steel bars. So let's push that right on, and then there's another one of these rings that fits on, and that fits against a stopper again in the opposite direction. Those fit on a base, but we've now sprung those 2 clips with some bungee cord, and that bungee cord actually goes through a curved hole, so it's tied off on one side, and it goes through a hole all the way round to give us some tension. So those things now spring against their stoppers, and they both do the same thing. So let's put some bearings on. This is for the actual handle that I'm going to turn on my twist grip, and that has an end cap which screws on as well to hold it in place. We've then got the actual twist grip piece which has a stick attached to it, and as you may have guessed, that fits on. It's quite a good fit on those bearings, and that also has a retainer screwed on to stop it falling off, and a retainer on the back that goes the other side of the bearing, so now that twist grip is fitted on. So as you may have guessed, that stick goes between the 2 pegs, and now as I turn the twist grip, it centres, and it's actually locked dead in the centre because of those 2 clips springing against their end stop. So there are 2 magnets pressed into that retainer plate, and I've got a Hall effect sensor that senses the distance from the magnets. So now this gives me the sensing in each direction. On the screw bike I had only 1 direction twist grips and a direction switch for steering, which wasn't very good. And I've got 2 of those fitted onto the handlebars, with that connector that mates with the one coming out of the electronics. I made shrouds to cover the mechanism too. So if I turn this left-hand twist grip, this is steering, and it goes in both directions, and one direction should make me rotate clockwise, and the other one anti-clockwise. Let's just check we've got enough space. So, This just makes one wheel go one direction and one go in the other direction. Which seems to be working pretty good. Oh, that's made me dizzy. Let's try the other way. So I do have a filter knob as well, which I can turn up, and we can turn up the deceleration so I stop more gracefully. So that seems to be working pretty good. And then the other twist grip should make me go forwards and backwards. So if I turn this one forwards now, it should drive all those wheels to bring me forwards. I can actually hear the wheel spin because these wheels are at that weird oblique angle, so they're not quite as good at going forwards and backwards as they should be, but that does actually work. So we might have to think about another solution to help push it forwards, but for now I can actually manoeuvre this around. Let's try and go forwards. Oh, that's very difficult in here. There isn't a lot of space in here, but let's try and go forwards and turn left at the same time. I'm going to hit something there. Whoa, whoa, whoa. So yeah, this seems to be all right. Good, right. Yeah, it's okay if I accelerate very slowly, but otherwise we get wheel spin. So we're going to, decide what to do about that. Wish I had some more driving space. I've added another drive unit to the back wheel, but kept it in the same orientation so that motor just helps push it forwards and backwards. And I've only done the back wheel because my mass is there, and that's just got a T5 pulley driving the bike directly. I've had quite a lot of problems with static electricity building up in these balls and between the Omni wheels with the brass bushings and their little rubber wheels. So I've battery grounded the entire chassis and all of the isolated metal with these wires. The hubs and axle of the Omni wheels are grounded through these wires that sort of drag round in a hole in the middle as it rotates, and I've got little wires going to the hubs. So now everything, all of the metal, should be grounded all the way through, and we've got continuity between all of the plates. Otherwise, I keep getting static shocks when I touch some of the metal plates, and I've also noticed a few glitches, which looks like the ODrive's cutting out, probably when static builds up and then discharge hundreds of thousands of volts. Right, so that back motor should give us much better acceleration. We still do get wheel spin if we overdo it, but it's much more reliable at going forwards and backwards. That feels a lot better on the whole, a lot more responsive. But we need a bigger area to test it. And that's why it's not good at high velocity, because the wheels pop out. So here's the spin outs where those Omni wheels of the rubbers come off basically and scuffed all of the ball. And also these are filthy already, which the dust is going to basically make it more slippery and less traction. So I'm going to give them a good clean. So you'll notice when I'm driving in a circle, it's really hard for it not to drift outwards, so I have to lean in all the time to fight it. And that's because the centrifugal force is pushing me outwards all the time. So, wait, I've got two controls. One of those is lean to steer, and the other one is steer to lean. So the first one, if I turn this knob up, and now I lean, it should steer. But I don't know how much use that's going to be because the centrifugal force is still going to try and upright me. So let me, without steering with this twist grip, try to go forwards and lean. Oh, okay. It's... Oh, kind of very difficult actually to steer and keep pointing in the right direction. Let me just try this. Let me lean first and try and go forwards. No, that's terrible. Right. The other control is steer to lean, which means that if I go forwards and I steer with these controls, it takes the sum of those, and then instead of trying to balance me at 0 degrees, so I'm upright, it balances me at a varying amount into the turn. So instead of drifting outwards, it should handle a bit more like a normal bike, and I should be able to drive in circles better. So let's just give that a little bit and see what happens. Hopefully it starts leaning to my left. Okay, that's not enough. Let's turn it right up. I've never tested this before. Okay, so yeah, I can feel that leaning inwards. It still drifts out, but it's actually much better. I feel like I can handle this much better. This is great. That's a lot more successful than earlier. Let me try some more.